Yeah. Okay, so we're gonna get to the bottom of this. You know, I came up with a we're yeah, like these. Okay, so like these. You probably watched the prior video, but like these are like Boolean functions that are each column. This Boolean function that's like maximally distant from every possible input identity function. And we have observed empirically that that distance is 37.5, and we're trying to kind of like bound or like determine what happens when you increase n, the dimension. And we're using matplot and like no, that's basically all we're using. Like we don't that's like our level of like mathematical sophistication is matplot. So anyway, lib dot plot. So anyway, let's just. Oh yeah, let me explain the idea. So the idea is we're trying to answer the question of, if you look at linear threshold functions and you look at it for each LTF, you look at its correlation with each of the input identity functions, and you look at the max correlation for an individual LTF with each input identity function, and then we're asking, what is the minimum over the LTFs of their max correlations with each input identity, and particularly as in scales, as the dimension scales. And yeah, we came up with a possible thing where you what we're going to do is we're going to look at the functions that are maximally distant from input identity functions. We're going to look at their accept sets, like the actual points that, you know, like are being accepted and or rejected. And then I think you can make like some sort of argument about, it seems like you might be able to make some sort of argument there if you look at the accept sets, like the actual points that are being accepted. Yeah, so that's what we're gonna do in this video. We're gonna, so there's gonna be a little bit of coding because I need to be able to. We're going to have to visualize the accept sets, and then you know, then we'll see how it goes. So, all right. So these are n equals 4 linear threshold functions that are also balanced, so they have equal number of. Just for culture, we can redo this without the balance constraint. So I just like this. That's the constraint that sets the bias to 0. So if we turn that off, we'll get like a different thing. Yeah. you know. So those are like, those are general LTFs. So anyway, we're only looking at the balanced ones. Not for any particular reason. There's just less of them, so it's better. Also, they look cooler. Like, they produce more aesthetic matrix plots, isn't it? Indeed. I don't know why this defaults to purple and yellow, but okay, so I already distracted myself. So yeah, okay, yeah, all right, right. Okay, so I'm just gonna run this and it should work. Okay, what the? All right. Yeah, so for n equals 4, I believe the max correlation is actually 0.5. Yeah. Yeah. Okay, I think I have to go to n equals, we're gonna have to bump it up. We have to go to a higher dimension because, I think if it's, I'm not sure a pattern, like, I'm not sure you'll be able to see a pattern of it's 0.5. You might be able to. I don't know. Okay, so this is like n equals, these are 5-dimensional functions. So there's like 32 rows. And you might be wondering, why is there a circle here? An oval? And the answer is, I don't know. Right? That's a hell of an oval, though. It's very nice. Okay, so now this should now work. Yeah. Okay, cool. Alright, so these... Wait, why is that? Okay, so these are functions. These are a subset of these. There's 1882 of general balanced n equals 5 LTFs, and then I guess that's 32. 32 of them are have correlation of 37.5, which is also the max distance you can get. And I think I also have a printout somewhere. Why am I not doing the printout? Yeah, I want to print this. Yeah. Yeah. No, it's not gonna let you print the whole thing. That's cool. Okay, so anyway, the idea of the video is we're gonna take one of these columns and we're going to basically just redisplay it as a also there's a lot of I guess you could drop, like, there's some negations happening here, so, like, but anyway, we're gonna take, like, the first column, and then we're just going to display, the first, like the purple rose. Purple rose. It's like a song or something, isn't it? Purple rose. Or, yeah, I don't know. Yeah, so we're gonna do that. That'll be cool. Okay, so I need a new cell. Nice. And yeah, we'll just put it as a subcell. So yeah, so like display except set of a max dist LTF, like from inputs, and then derive argument about scaling within, right? We're gonna do all that in this column. Okay, so I need to figure out what I'm calling this matrix. I'm not calling it anything. Or, no, where is it? It's here. So although I just realized like I'm sorting, and now I'm confused about the order of sorting, so I'm going to do this in its own cell. That'll be weird if that drastically changes everything. I don't feel like it would. One, two, three, four, five. Okay. Yeah. Okay, so we'll just reproduce this down here. Yeah, like that's the same, I think. Yeah. Okay, so then we're gonna. Okay, so we need to name the matrix. Yeah. So we'll call that. Right. We're just selecting. Also, if you wanted to do like sanity checks, we could just say like what if the minimum distance was 1, right? That should give you the input identity functions. That's gonna break. Oh, it worked. Oh wait, did it? Yeah, I just made it very large for some reason. Why is it so big? Are these input identity functions? Well, I mean, it's input identities and their negations. Is that right? Yeah. Right. Yeah. So I mean, like those are the input identity functions and their negations, and we're trying to find LTFs that are maximally distant from those. Yeah. Okay. Well, which empirically is 0.375. So that's why we're typing in 0.375. Yeah. Okay. So then we're just gonna do the thing where you we're gonna take the first column of this matrix, and we're then going to, let's see, do I actually have the inputs? I think they're just called X. Although I might, Yeah, okay, I need to get rid of the last column. Let's see, all of the rows, drop the last column. Okay, so like inputs are just, you know, like your binary numbers, you know, in 5 dimensions. So this is like 0, 0, 0, 0, 0, and then 0, 0, 0, 1, so forth. Okay. So then we're going to look at the first column and figure out which of those this first column is accepting. Because it's like, I feel like there's some basic argument about, like, you know, I mean, like, yeah, like if you're far away from an input function, and then you look at the accept set, and then you look at the columns, each column has to, like, yeah, I mean, this might not work, but you know, we'll definitely figure out the NP code. Possibly. Okay, so I need to select a subset of inputs. Okay, so I'm gonna pick F to be max dist F's all of the rows and the first column. And then, yeah, and then we're just gonna do like, np where F equals, -1, right? And, let's like print that. Zero, 1, 2, 3, 4, 5, 6, 8, 9, 10. Yeah, I'd say that worked. Okay. So then we're going to subset the inputs with this. The rows. And then just plot. Why is it making it so big? Jeez. Yeah. Yeah. Dang. Let's look at another function. We were looking at we're looking at the 0 function. Okay, let's look at 15a. Right. Right. Mm-hmm. Mm-hmm. I mean, okay. Let's do another one. Let's look at 10. Ooh, yeah. Yeah. Let's look at another one. Six. I don't know where that one. What's that here? Right. Yeah. Okay. I mean, there's definitely some sort of pattern happening. What if we display all of the yeah. What if you sort the inputs by the value of no. Okay, well, so each column is always split. You know, like this column has like 5 purples and 11. Because, I mean, there's always 16 rows. Yeah. So they're all like 511. And they're all 511. You know, which is probably combinatorially necessary. But the 5, I don't quite see why it would have to be 5. Yeah. Yeah, okay, I think I'm gonna display both the accept set and reject set. That should be cool. Yeah. Right. So I forgot how to I forgot how to do subplots. So yeah. Okay, and not plot. I would like 2 plots next to each other, please. You always have to be polite with AI. Yeah. No. 1 row. Oh, I see. Okay. Yeah. Is this right? I don't even know this. One row, two columns. What's the other number? Oh, I see. Right. Okay. Alright, so then I just need to do, I think, like, yeah, this part. And, I think, like, this part will go here, and then the other one goes there. So cool. No, that didn't work. That didn't work at all. So that's supposed to be one, actually. Do I have to do that stuff? Okay, yeah. This is like not working. One row, two columns. Do this. Nice. Yeah, it doesn't like match show for some reason. For reasons we will never understand. Okay, so yeah. Okay, alright, we're back. Good. Good, yeah. So I mean, this is the accept set. This is the reject set. I mean, like, obviously they are reflections with negation or whatever. So yeah. So I mean, what then really? Wait, is this? Yeah. Yeah, they're all yeah, okay. Well, one more. Let's see. Yeah, I think, yeah, like, well, I'm gonna do one more, which is, take, I guess it would be like, take these functions and, yeah, it would be like, display them in terms of, difference with one of the input identity functions. I feel like there should be like some counter argument going on, but who cares? So yeah, I'm just gonna do that thingy. Oh no, I broke it. Yeah. So we just want this. Oh, did I mess that up somehow? Okay, so we just want okay, do I have right? Okay, so I said this bill is where each of those is equal to IIDs, like the first one. May or may not work. Different one. Let's see. We shall do subplots. Okay. Right. Okay, so I want 5 columns. Do I, and then do this. Right. Okay, then to a stupid thing. Oh man. Okay. That looks cooler than I thought it would. Great. Yeah. That's like a guy. He's the LTF guy. He's like, hey. But cool. And then whenever I don't really have any ideas, we're just gonna we're gonna go back to n equals 4, you know? N equals 5 is really too brutal, to be fair. Whoops, what just happened? Wait, yeah, I'm gonna go there. Okay, n equals 4, and then I think we wanted to go here, except this has to say 5.5. And that needs to be in. I need to recalculate D. Where does that happen? Over here. Then go down, recalculate. Oh no. 16. Not sure why that doesn't work. Right. It's 32. Each of them are 32. Okay. Wow. Well, no, we're back in program. I'm just gonna do it. I'm gonna do n equals, like 6 maybe? Just because it'll look cool, probably. Oh, then I'll call it. Yeah. Do you think that's everything? This is 375. So we can go back to this. needs to be bigger. And then right like 16, make this like 1, like 2. Yeah, that actually did not look cool. Just do one more thing. It might do. $192. So only take the first whatever 192 divided by 2 is. Is that gonna work? Probably not.